Hi folks, I'm using the new version of Excel here in order to demonstrate how to plot some graphs. Okay, so let's go ahead and get rid of this. All right, let's say we have two variables here, time and distance. Time and distance. The system that actually produces these values doesn't really matter so much. As a matter of fact, I put some of these are things with random functions in them, like, okay, it's like 2 times the time step over here plus a random number minus 0.5. What I wanted was I wanted some kind of randomness to the numbers I come up with. Okay, but you're going to have plenty of that with measurement uncertainties, and we'll talk more about the different kinds of uncertainties that you can have in your experiment. But let's just say that we have our two variables here. We have a dependent and independent variable. Here's your independent, here's your dependent variable. Okay, and your mouse skills are probably much better than mine, but I'm going to highlight that entire set of data there, just the data, not the labels, and I'm going to come over here to insert. I've got insert, and then I'm going to look at charts, and there's one here that says scatter. Insert scatter XY or bubble chart. So I'm going to select that. And I'm going to select this first one here. This is a scatter chart. This is your basic tool. This is your basic tool for data analysis. Okay, so we could chart title. I'm just going to type in time versus there we go. Time versus distance in turtles. I just made that up. Okay, and you can go in here and you can add axes and things of that sort. Okay, but here's the important part. What we want to do now is we want to insert a best fit line. Notice that this this line, this is not falling into a nice pattern there. Okay, but let's add a trend line. See that selection there? That was add trend line, and this looks as basically linear. Now, if we'd had like a big upward ski slope or a cliff that had come off, we'd have chosen a different kind of function. But this is essentially linear. Well, close enough. All right, and let's see if I can't. Okay, I've got linear selected. Notice here's your cliff, and here's your exponential, and here's your power laws and moving averages. Okay, you can look all those up later, but I'm also going to put here display equation on chart and display R squared value. Now, if you have taken statistics in the past, those are going to have meanings to you. Right, that R squared value. Let me see if I can make, no, can't really make that any bigger. Okay, and let's see. Let's go ahead and let's close that because we've already done it. And there's your best fit line, the equation of that best fit line, and your R squared value. Now, your R squared value is basically a measure of how well a linear line fits this data, and away we can go with that. Okay, now notice here that we've got this big deviation up here. It's all kind of close together down here, but this big deviation. Okay, the R squared value is not really very good. All right, now let's go up here and let's change this. See, the randomness that I've thrown in here is actually proportional to the this first value here. But what if I just make that standard? What if I just make that times 1.0? So the randomness is going to be the same no matter where we are on the graph. Okay, so let me just do that, and I'm going to copy and paste that down. Holy smokes, look at that. The randomness is, okay, none of these points are actually straight on the line, really on that line. Some are above, some are below, and the ones above are equally scattered on the high side of the graph and the low side of the graph. Okay, so that's a pretty good fit there. All right, so let's see. Slope would be about 1/2 times our independent variable. 1/2 times our independent variable. times with a very small change for the y-intercept. It just comes from the randomness. But you can see here what happens to the r squared value. The r squared value has shot up to 99.59, or 99% of the variation in the values on this graph can be accounted for by the changes in the independent variable. Let's see if we can't make that a little bit bigger there. Let's make that 5 times. Is that right? Did I do that? Nope. Oh yeah, it's 5 times. Okay, so let me copy and paste that down. All right, so I made the randomness in the data. I made that 5 times the size it was before. Okay, and we can see that the best fit has gone down to 95%. R squared is 0.9538, or 95% of the variation can be accounted for by the change in this independent variable. Okay, and you can play with that for a little bit if you want. But again, we have that equation of a line right there that can give you the measurement of a parameter, for instance. Okay? Play with that. Have a good time. And I'm going to include a link to this data set, in the notes to the video, so that you can play with this yourself. Have a good day.